This will be classwork 3.3, number 26. And this problem says, calculate acceleration due to gravity on the moon. The moon's radius is this and mass is this. Okay, so let me just, before I start this, point out that at this point we have three different types of gravity. We have little g, which little g is acceleration due to gravity. Okay, it is the rate of change of your velocity. Okay, it is an acceleration. Okay, it is in the units meters per second squared. Okay, now when you accelerate, when something is accelerating, it's caused by a force. So the acceleration due to gravity is caused by the force due to gravity. Okay, and remember this is in newtons. And we know that the force due to gravity between any two objects is equal to our equation, the universal constant for gravity, m1, m2, over how far apart they are, squared. Okay? So in this case it says, what is the acceleration due to gravity on the moon? All right? So I know that this would be the mass of some person and the mass of the moon. Okay? And this right here is the force due to gravity, which remember is the weight of something on the surface. Okay, it's the weight, which we know is mg. Okay, so if an astronaut was standing on the surface of the moon, his weight, m of the astronaut, g, is going to be equal to the mass of the astronaut times the mass of the moon, all over the radius of the moon squared. Okay, why is it just the radius? Well, if we have the moon and you have a little astronaut here, the moon is going to be so relatively huge that this person's center of mass does not matter. This person is essentially one radius away from the moon's center of mass. Okay? And the mass of the astronaut cancels out. Okay? Which is why your own mass or something's mass doesn't affect the force due to gravity, or sorry, not the force due to gravity, but the acceleration due to gravity on a planet. Okay? It's not affected by mass. So here we're trying to find g. We have 6.67 times 10 to the negative 11th. We have the mass of the moon, which it tells us in the problem is 7.35 times 10 to the 22nd kilograms. Oops, I guess I don't really need to put that out there. All divided by the radius squared. So 1.74 times 10 to the 6th, and it gives me it in meters, so I don't have to change that, squared. All right, I'm always going to start by punching that in first, just because I want to make sure that I'm squaring everything appropriately. I'm just going to write that down. So 3.03 times 10 to the 12th. Okay. And then I can just punch everything in. So 6.67 EE to the negative 11th times 7.35 EE to the 22nd, all divided by 3.03 EE to the 12th. So I get 1.6. Right? So g equals 1.6, and the unit is meters per second squared.